your first assignment, so if you're talking to people in the other section of the course, they had an assignment come out last Thursday. The other instructor didn't tell me they had another assignment coming out last Thursday until yesterday. So your assignment comes out later today. So your assignment will be different than the assignment in the other section, which is fine. They're roughly the same difficulty. So your assignment comes out today, probably early this evening, and it'll be due a week from today. And then it's actually chained with assignment 2. So as soon as you finish assignment 1, next week you'll be able to roll right into assignment 2. And they're connected to one another. So they build on top of one another. Any questions in the course so far? All right, so by the end of this week, OnQ will be completely updated with the final dates, with the firm dates of the quizzes, and hopefully all of your assignment due dates, or at least the tentative assignment due dates. All right, so let's pick up from where we left off in the last lecture. So we were talking about using strings in char, right? So char is this type, it's a primitive type, so don't forget it's primitive, right? Char literals are inside single quotes, right? There's no such thing as the empty char literal, right? So you can't have single quote, single quote. There has to be one character in between the single quotes. There can be more, but if there's more, then you have to write them in a special way. And that's not really relevant for our purposes right now. If you're interested in it, though, you can ask me about it, or you can look it up online. What else is there? Okay, so you can do arithmetic with char, but the results are very unusual. Right? So for example, I can start out with the char A, and I can write plus plus, or plus equals 1, or minus equals 1, and everything is fine. Right? Those all work. So after plus plus, C is the letter B. Add one more. C is now the capital letter C. Subtract 1, C is now back to being the B. Right? But when you try to write C equals C plus 1, which you might have been told in Python is basically equivalent to that or that. It doesn't work. And it's odd, especially for people who are new to the Java language or to C, because I think it works the same way in C, why this doesn't, actually it doesn't work quite this way in C. It doesn't work. Anyway, so in Java, that last line there doesn't work, C equals C plus 1. Right? And it's very weird. Right? So it turns out that for each one of these operations, so here you've got plus plus, you've got plus equals, and you've got minus equals. If you actually go and look at the language specification, so the language says that each one of these operators behaves in a particular way. Right? And it turns out that the way they behave is actually differently than that last line there. So on that last line there, what does Java do to compute the result? Well, it sees a char, right? Because C is char. And it sees a 1, right? So a 1 is an int. And a C is a char. So when you take a char and an int, Java says, I don't want to add these two things together because their types are different. Right? So it tries to convert one of the two types to the other type. Right? And the rule in Java is you try to convert the type that's narrower to the type that is wider. Right? So int represents a wider range of values than char. So the compiler converts the char to an int. Right? And now you have an int plus an int. Right? And so the result is an int. Right? Can you store an int in a char? The answer is in Java, no. You can't store an int in a char because an int is wider than a char. Right? So Java won't automatically store the result in an int. It'll say there's an error instead. Right? Okay, but it gets weirder. So if I start out with another char D and I try to add C and D together, right? You say something like, but professor, you just told me if Java looks at the type of C and the type of D to determine can I add these two things together. Right? So there's a char and a char. And so most people would think Java computes the sum as a char, and they would be wrong. Right? So it turns out the rule in Java is if your type is narrower than int, right? So any type that's any type that's below int. So byte, char, short, char. Sorry, byte, char, short. Right? If you try to add those together, Java automatically converts those to int. Right? Why it does that? I don't know. That's the way the language is defined. Right? So it converts that C and the D to an int, sums it together as an int, and now you're back in the same situation. You can't store an int in a char. So you have to be a little bit careful when you do arithmetic with char. Now, why would you want to do arithmetic with char? Because sometimes it's useful. Right? So sometimes when you're generating strings, or when you're computing the value of a string, right, I want to add together a bunch of chars. Right? And so an example of this is what happens if how would I compute all the strings that are made up of two letters, right? Two uppercase letters. Right? And so the obvious way is to write a loop, or to write a nested loop. Right? So my first loop, where the loop variable is c, right? We start at capital A. We go up to and including, right, less than or equal to, the z. Right? Each time through the loop, we increment c by 1. Right? So A, B, C, D, E, F, G, all the way through z. And then you just repeat the loop in the inner loop, this time using a different loop variable. Right? So the inner loop also runs A, B, C through z. Right? And then inside the inner loop, I can just concatenate those two strings together. Right? Notice the way I do it, though. I start with the empty string, right? And then concatenate that with this letter, the character C, and then concatenate that with the character stored in D. Right? I have to write it this way. I can't write C plus D, right? Because C plus D, right, on the previous slide, I just showed you that results in an int. It doesn't result in a string. So if I want to do string concatenation here, I have to make sure that we start with a string. Right? So we start with a string, concatenate that with a char. Right? Java converts the char to a string, joins the two strings. Right? Then you have a string plus a char, or concatenated with a char. Java converts the char to a string, and then concatenates the two strings. Right? And then you can print out the string, or do whatever you need to do with the string there. Right? So there's an example of when you might consider using arithmetic with chars. Right? There's lots of other examples too that you can come up with. All right, so this thing called string is a type, right? And it's also a class. Right? Back here, the result of the empty string plus C plus D, that's a string object, right? And so what do I mean by these things, types, classes, and objects? So a type is a set of values and the operations that you can perform with those values. Right? So int is a type. Right? What are the set of values? Well, the set of values from integer min value to integer max value. What can I do with an int? Well, I can do arithmetic with ints, I can compare them, and I can do a few other things as well. Right? So int is an example of a type. Right? Now, what about string? Well, string is also a type. Right? So what are its set of values? The empty string plus any sequence of characters joined together. Right? So that's the set of possible strings. What operations can I do with strings? Well, you don't actually know. Well, you know you can concatenate strings. But it turns out there's a whole bunch of other things you can do with strings as well. Right? And so a class defines a reference type in Java. Right? And as a programmer, you're allowed to make your own classes. Right? So you can make your own types, which turns out to be enormously useful. Right? Finally, what's an object? Well, we say an object is an instance of a class. And you say, well, what on earth does that mean? Right? And so what it means is to make an object, you take the class and one way to think of it is you take the class and you basically duplicate the class. Right? And that produces what's called an object. Right? That's not exactly what happens. It's close enough for our purposes. Right? So an object is just an example of an object is just something, right? A piece of something in memory whose type happens to be some class. Right? So the number 5 is an int, right? So the number 5 is some chunk of memory that represents the number that has the same type as int, right? The string ABC, well, that's just some chunk of memory that happens to have the type big S string. Right? So the string class is just the class that represents text, right? A sequence of characters. Right? So by sequence we mean there's a first character, then a second character, then a third character in the string. Right? And strings are very widely used in the Java language. They were considered so important that they were actually placed in a special location When we talk about packages, they're placed in a separate package. We'll get to the packages in a little bit, right? And they're also given extra special treatment. You can do stuff with strings that you can't do with most other objects. Most other objects. Right, so for example, there are string literals, right? I can write double quote, put some stuff inside the double quotes, and I have an example of a string that you can write down, right? There are no other literals for any other reference type in the language, right? The plus operator is defined for strings, right? No other arithmetic operator is redefined for objects of any other type, right? So strings are special in the Java language. There's other things about strings that make them special, but that's not important right now. Okay, so if you follow that link there, that will take you to the documentation for the string class. Later on, I'm going to show you how to read the documentation for a class. For now, I'm just going to describe what you can do with strings. Okay, so like Python, right, if you make a string, you can't go in and change the characters of the string, right? So strings are immutable, right? So as soon as you make a string object, so for example, hello, right, then there's no way that I can take that object and change the characters H, E, L, L, or O, right? That object is forever the string hello, right? And that's going to seem weird to a lot of people, especially, well, it seems strange if you come from a language that's not Python, I guess. So for example, if you come from a language like C or C++, this is very weird, right? In Java and in Python, strings are immutable, right? They represent a fixed sequence of characters. So if you run a method, and the method looks like it changes the string, it doesn't actually change the string, right? What the method does is it returns a new string object. So for example, right, there are these methods called toUpperCase and toLowerCase in the string class, right? They do exactly what their names say they do, right? toUpperCase takes a string and returns the uppercase version of the string, right? toLowerCase takes a string and returns the lowercase version of the string, right? Without modifying the original string. So we start out with this string reference S, right? So S refers to the string hello, right? Now, how do I call this method hello? How do I call this method toUpperCase, right? So I don't call it like a function, right? If it was a function, you would write toUpperCase and then S inside of the brackets, right? That's not how it works in Java. So in Java, you take the object reference, then you write a period, so S dot toUpperCase, right? And so the way you should think about this is you are asking the string referred to by S, what is your uppercase version, right? And so here you can think of this method toUpperCase as sending a message to the string object that's referred to by S. You probably did a little bit of this in Python because I've been told you did a little bit of object-oriented programming in Python. So you probably saw something like this. Okay, so if I call toUpperCase, toUpperCase returns a new string object that's the uppercase version of hello, right? So in other words, it returns a string capital H, capital E, capital L, capital L, capital O. Right? So if I print the value of S, right, you get lowercase hello. And if you print the value of up, you get uppercase hello, right? Notice that S doesn't change, right? So the method doesn't change S, right? It computes a new string that is the upper or lowercase version of S, right? So this is the common mistake that a lot of programmers new to Java make, right? They forget that strings are immutable, and they want so if they want the uppercase version of S, or if they want to write something that converts S to its uppercase version, and you can't do that, right? So they'll write something like S dot toUpperCase. So the toUpperCase method runs, right? Computes the uppercase version of S, and then returns it back to the caller. But the caller doesn't keep the value, right? There's no assignment here, right? And so the uppercase version of the string is lost, right? It disappears off into nowhere, right? And now they no longer have the uppercase version of S, right? And they're still stuck with the lowercase version of S, right? So if you call a string method, you almost always, you either want to use the result right away, or you want to store it in a variable somewhere. So that doesn't work. So remember, all the string methods, if they look like they change the string, they don't. They return a new string. All right, so those methods, toUpperCase and toLowerCase, those are what are called non-static methods in Java, right? So in week 1, I told you, look, for now, everything is static, right? So now I'm telling you there are also these non-static methods. So a non-static method is just a method, right? Normally, if you say method, you mean non-static method. If you say static method, then you mean static method, right? So to call the method in Java, you need an object reference. Right? So to call the toUpperCase method, I need some object that's a string or refers to a string. Right? So s.toUpperCase asks the object s or the object referred to by s, what is your uppercase version? Right? Now string has static methods as well. Right? So don't forget everything you learned in week 1. If it has a static method, the way you call the static method is with the name of the class. Right? So there's a method called valueOf. There's actually multiple methods called valueOf. Right? So there's one version for each primitive type. Right? So there's a value of Boolean, there's a value of int, there's a value of short, and so on and so on and so forth. Right? Those methods let you pass in a primitive value, like 1.0, right? And then the string class computes the string representation of 1.0, right? Which is just double quotes 1 decimal 0. It's a static method, so you use the name of the class to call the method. Right? If you think about this for a second, right, it makes sense that this is a static method. Right? If I want to compute the string version of the number 1.0, right, it doesn't make sense that I need a string object to compute the string representation of 1.0. Right? If I had a string object that knew what the string representation of 1.0 was already, I would just use the string object, right? So here you don't need an object to compute the string representation of a primitive type, right? You want the class to compute the string representation of the primitive type. Right? So valueOf, you can use valueOf if you want to, but if you ever need to convert a primitive type to a string, the easier way to do it is just to write empty string plus the value of the primitive type. So, or for example, let's do double x equals 2.0. Right, so string u equals plus x, like that. Right, so you can also use variables in these calculations, which makes sense, right? Otherwise, variables wouldn't be so useful. Right? So you can also use string concatenation to convert a primitive type to its corresponding string. Right? And in fact, when you do this, right, when you do the string concatenation, internally what happens is the compiler ends up calling valueOf for you. Right? So when the compiler sees this, it calls valueOf on x and then joins the resulting two strings. So don't forget, if you're calling a static method, use the name of the class. If you're calling a non-static method, you need an object reference. All right, so like in Python, a string in Java is a sequence, right? So that means you can use an index to get to the individual characters, right? Each character has a unique index starting at 0, right? The last valid index is the length of the string minus 1, right? Just like in a Python sequence. Right? Now, unlike a Python sequence, you cannot use negative indexes in Java. Right? So -1 in Python, the index -1 would be the index of the last character in a string. Right? You can't do that in Java. In Java, you have to compute the length of the string -1, which is awkward, but that's the way it works. Right? So for the string CISC124, right, capital C has index 0, number 4 has index 6, so on and so on in between, right? Okay, if you want the length of the string, then you just ask the string how long is it, right? There's a method called length that tells you how many characters are in the string, right? It's not the function len like it is in Python, right? There are no functions in Java, so you have to call the method, right? Why do I need an object to call the length method? Because I'm asking an object, how long are you, right? I don't want the string class, I don't want to have to call, well, sorry, in Java you don't write a static method to find the length of a string, right? You just ask the string, how long is it, right? So if I have a string reference called course name, I can write course name.length, and I'll get the number 7 in this example, right? There is an empty string, right? So double quote, nothing in between, right? The empty string has length 0, right? And so whenever you write a method that involves strings, right, you have to, you should always be thinking, well, what happens if they call this with an empty string, right? Because it turns out this is going to be one of the special cases that you have to deal with whenever you work with a sequence of some kind. Okay, what if I want to get an individual character in the string? Unfortunately, I can't use square brackets, right, like you would in Python. Right, so instead you have to call a method. What's the name of the method? Well, the method's called charAt. Right, so it's charAt, pass in an index, the string will return the character at that index. Right? If the index is invalid, you get an exception. Right, so if you want to loop over the characters of a string, it's straightforward. Right? You start at 0, right? So my index I starts at 0. The index I goes up to, but not including the length of the string, right? So less than the course name.length. Right? Each time through the loop, add 1 to I. Right? Now inside the loop, just ask for the charAt I. Right? So ask course name, what is the character at index I? Right? And then use the character for whatever you want. Right? Here I'm just printing it out, but you can do whatever else you want with it. Right, so charAt instead of square brackets in Java. Right, if you want to count the number of times that a character appears in a string, this is just straightforward linear search. Right? So I want to count how many times does target appear in S. Right? So how do I do this? Well, make a variable called count, starts at 0, write a loop that loops over the characters of the string. Each time in the loop, ask S, what is the character at I? Right? And check, is it equal to the target? Right? Now, that's a primitive type, right? Target has primitive type char. So for equality of primitive types, you use equals equals, right? Or not equals for not equals, right? Exclamation mark equals for not equals. Right? If I find the target, then I add 1 to the count, and then at the end of the method, I return the count. Right? You don't return the count from inside the loop, right? You return the count outside the loop. Any questions so far? Should be pretty straightforward, I think, for most of you. Okay, how do you use the frequency method? Well, you just call it like it's, you just call it as though it were a static method, right? So it is a static method inside the class strings, right? So static strings, right? So to call the method, strings dot name of the method, pass in a string reference, pass in a target character. Right? So how many times does capital C appear in CISC124? Well, twice. Right? What about lowercase c? Right? So case matters. Right? So lowercase c appears 0 times in CISC124, and the 4 appears once in CISC124. Okay, string also has a method called contains. So contains returns true if a string contains a specified substring. So for example, there's my course name, CISC124. Right? I can ask, does the course name contain the substring, all caps CISC? Right? And the answer is yes. Right? It's right there, CISC. Right? Does it contain the substring little case CISC? The answer is no. Right? Does it contain the substring 4? The answer is yes. Right? Okay, can you use contains to search for a car? The answer is no. There's no version of contains whose input is a car. So if you try to write course name dot contains uppercase C, right, the compiler says there's no method called contains that takes a car. Right? There is a method called contains that takes in a string though, so you can convert the car to a string and ask, do you contain that string? Right? So you just play the same trick that I showed you on the previous, a few slides ago. Take the empty string, add your primitive value, right? and that gives you the string representation of the primitive value, and now that works. Right? The contains the substring has to be it has to be a proper substring, right? So if you asked, does this contain the substring C2? The answer is no, right? It contains C12, but you can't skip over characters in the substring, right? So it has to be a proper substring. Index of returns the first location of a character or a substring. So it turns out there's two versions of index of. Right? So if you want to know where is the location of a character in a string, that's when you use one of the various index of methods. Right? So index of gives you back the index. If the character is not in the string, you get back -1 as the index. Right? So you get back an invalid index. Right? So where's the index of the C in that string? Well, it's the first character, so that has index 0. What about the S? Well, it's the third character, so it has index 2. The 4 is the 7th character, so it has index 6. Right? There is no little case z, so it has index -1. And so you can, if you want to know does a string contain a character, you can always use index of. Right? String dot index of the character you're looking for. If the result is -1, it's not there. If it's not -1, so if it's 0 or positive, right, then you know it's there. Right? So you could write your own version of contains that works with chars. Right? If you want to know what is the index of the last occurrence of a character, then it's last index of. Right? And there's a bunch of other index of methods as well inside the class. Right? So where's the last C in CISC124? Well, it's the one in the middle. Right? So the one at index 3. Right? Where's the last S? There's only one, so it's at index 2. Right? Where's the last 4? Again, there's only one, so it's at the end of the string. There's no Z, so again, you get back -1. Okay, this is important, right? If this is the only thing you take away from this lecture, make sure it's this slide, right? If you want to test if two strings are equal, right, always, always, always use the equals method, right? Do not use equals equals or exclamation mark equals to compare two strings for equality, right? So for all of the primitive types, right, if you're using ints or doubles or a float or char, right, if you want to test if two of those things are equal, use equals equals or exclamation mark equals, right? Whenever you're working with objects, right, so whenever you have a string or almost anything else in Java, right, that's not primitive, right, use equals, right? So I want to compare the string CISC and math, right? So CISC dot equals math, right? So it's asking, is CISC the same string as math, sorry, right? By same string, I mean, are the lengths of the string the same? Do they contain the exact same sequence of characters? Right? So the answer in this case is obviously no. Right? So that's false. Case matters. Right? So CISC dot equals lowercase CISC124 is false. Right? Those are two different strings because the letters don't match exactly. Right? Now, the problem with the string class is it's special in lots of different ways. If you write a simple little program and you use equals equals to compare two strings, it almost always seems to work, right? So you can have a student who produces lots and lots and lots and lots of test cases, right? And they'll show you your program and they'll say, hey, this works, right? Equals equals compares strings just fine. It doesn't actually compare strings just fine because string is special, right? So let me show you what I mean by string is special. So I'm just going to pull up Eclipse, and I'm going to cook up a, oh, shouldn't show you that. That's the answer for assignment 1. And I'm going to cook up a little example program here. Okay, so if you haven't used Eclipse yet, you should probably use Eclipse and at least look at that first video that shows you how to use Eclipse. Right? So I'm going to make a new project. I'm just going to go to File, New, Java Project. Okay, when you make a Java project on your computers, right, either make sure you're using Java version 8 or lower. Well, you want to use 8. Don't use a lower one than 8. Right? So either do that, or make sure that box down here is checked. You can't see it, I know, but I can't easily change the font size, unfortunately, inside the UI. There's a little box down here called module, right? Sorry, make sure it's not checked, right? So uncheck it if it's checked, right? If you leave it checked, you're going to get this funny file that appears in your project, and and if a lot of students either end up editing the file or they delete it, and then nothing works. Right? That little box there, that's a feature that was added in Java 9. But that feature is useful for when you build big pieces of software, not when you're writing one little test class. Right? So if you check it, whatever you do, don't edit the file that gets created when you check it. All right? So I would recommend you uncheck it, and that gets rid of all the problems that you might run across. So I'm just going to call this, what are we, lecture 5 or something like that? Yeah, lecture 5, right? When you make a project name, make sure there's no spaces in it. It doesn't have to start with a capital letter. So just give it a name. Don't put any special characters in the name. Right? Click next. Yes, click next, right? Yeah. And that's it. Finish. And that's going to make a little project over here called lecture 5. Right? Okay, so you double click on your project, and then in the source folder, you can make a new class. So new class, right? So I'm going to call this also lecture 5. Whoa. Sorry. What are we talking about right now? We're talking about, thank you, equals. Right? If you want a main method, check that box there. Right? The box says public static main, public static void main. Right? And then when you click finish, you'll get your class and you'll get your main method there. Okay, so let's try this out. So I'm going to make a string string s equals hello, like that, right? Then I'm going to do string t equals goodbye, like that, right? And then I'm just going to print out the value of equals, right? So system dot out dot println. So I'm going to do equals, the string equals, and then I'm going to do s dot equals t. Right? And then I'm also going to do the same thing for equals equals. Right? So I'm just going to copy that, do that, right? Equals equals, like that. Replace this with equals equals t. Okay, save that. Don't forget to save when you edit your file, right? If you don't save it, when you try to run your program, you get the previous version of the program that you wrote. Right, so save, run. There's a little green button up here that says run. It looks like a little play button. So if I run that down here, oh wait, how come I didn't get, oh, haha, classic mistake. Equals equals. Wait, I should have gotten equals equals. I should have gotten the string equals equals plus s. Why didn't it print out this? Dun, 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 dun. Strange. Hang on while I think about this for a second. Did I do something stupid? Equals equals. There's a string there. That string should have gotten printed no matter what. It's the first string. Strange. I will have to figure that out later. This is the problem with live coding, by the way. Things don't always work out the way you want them to. Oh, is there an error now? Where's the error? Oh, my fault. Okay. There. I'm going to have to look at that later on. Okay. So here we get false and false, but that's what you expect, right? Because they aren't the same sequence of characters. Now, what happens if I change them so that they are the same sequence of characters? So now they're both hello, right? So I definitely expect equals to return true, right? But why does equals equals also return true? That's annoying, right? It looks like they're the same, right? And if you try, right, you can even try to fool the compiler a little bit, right? So I can take two strings and join them together. The result is still hello, right? And I can try that. And it's still telling me they're both the same. And so at this point, most people who are learning the language say, well, I can just use equals equals to compare strings. And the answer is, and so it turns out you cannot, right? And so what happens when I change t to look something like this? New string, H-E-L-L-O. Like that. Right? So we haven't seen this syntax before. Right? So I wrote new and then string, and then inside the round brackets I wrote the string hello. Right? So the new operator in Java creates a new object. Right? That's why it's called new. Right? What type of object does it create? Well, it makes a string object. Right? Okay, so now I have two strings. I really have two string objects. Right? They're both H-E-L-L-O. So now when I run this program, equal says true and equals equals says false. Right? Which is also confusing, right, if you think that equals equals is actually comparing the sequence of characters. Right? It is not. All right, so what's going on here? So equals, that's the method that compares the sequence of characters in the two strings. Right? Equals equals is asking, do the references S and T both refer to the same object? Right? So do the references S and T both refer to the same object? It's not asking, do they have the same sequence of strings? It's saying, are the objects the same? Right? So here, I've got one string object right there. Right? I have a second string object here. Right? I have a second one here because I used new. Right? So I have two different objects. They can't have the same memory address, or they're different objects. Right? So equals equals is false. Right? S and T do not refer to the same object. Right? When you write the following, right? So when I change T so that it's the literal hello, right? The string class is clever, right? It sees you've used the literal hello twice, right? So it only makes one object, and it uses the same object for both literals, right? So in other words, the string class remembers the value of all the string literals in your program. If you repeat one of those literals, it just uses the string object corresponding to that literal, right? So there's only one string object in this example, right? One string object whose sequence is H-E-L-L-O, right? Equals returns true because it's the same string, right? So obviously the sequence of characters must be the same. Equals equals returns true, right? Because it really is the same object, right? S and T really do refer to the one object that's in memory, right? The one string object that's in memory, right? So the string class is special, right? It tries to be clever. It tries to save memory, right? It does other things that makes the programmer's life easy, right? It makes your life complicated, especially if you're a new programmer to Java, because equals equals doesn't work the way it should, right? Or the way you're expecting it to. If you ever have a reference type, right, remember to use equals, not equals equals, okay? So that's the take-home message from today's lecture, right? If that's what if you only remember that one thing, remember, use equals if you have a reference type. Is there a resume? No, this is it, right? There we go. Okay, any questions on that rather long explanation? All right. You've seen plus before, right? Plus is the concatenation operator. So it joins two strings to produce another string, right? So name 1 is James Bond 007. Name 2 is just the separate names all joined together, right? So James space, Bond space, and then 007. Right, join them all together. Are the two strings equal? Yes, they're equal. Right. Surprisingly, in Java, they're also equal. Right. Oh, so were you guys taught what same means in Python? Anybody? Same? Yes? No? I need an answer? No? Okay. So in Python, you can test if two references refer to the same object with same. I'm pretty sure. Pretty sure it's same, right? In Java, in Python, when you use equals equals, that corresponds to Java's dot equals, right? When you use same, that corresponds to Java's double equals, right? So it's the opposite in Java. Right? Plus, primitive values can be concatenated onto a string, so this is also true, right? So here I can make, start with a string, and then add a int 0, and then another int 0, and then another int 7 to the end, right? And you also get James Bond 007. Right? So that works. But you have to be careful about how you order the operands. Right? So if I write character H plus character A plus ha, right? I don't get ha ha. I get 201 ha, which is very strange. Right? And why do you get 201 ha? Right? So we have plus, right? So we have two plus operators. Right? When Java sees an expression containing operators of the same precedence, right, then Java computes the expression left to right. Right? So we have char plus char. Right? Java converts both chars to int and computes an int. So that's why you get the 201. Right? Now you have an int plus ha. So now Java says, oh, I'm joining an int and a string. So now I do concatenation. Right? So now I get 201 joined with HA, which is why you get 201 HA. Right? If you're concatenating something to a string, right, make sure the string is in front, or make sure the empty string is in front. Right? If you always start with the empty string, it solves all of your problems, right? And you don't get weird stuff like this. Okay, what about slicing a string? Right? So Python has this slice operator, which is super useful. Right? You can slice any sequence in Python, which is awesome. Right? So I can slice this string A, B, C, D, E, F, G to get part, or to get a substring of that string. Right? So I can write 1 colon inside square brackets, right? And that gives you everything except for the first character of the string. Right? 3, 4 gives you the character at index 3. Right? 5, 7 gives you the characters at indexes 5 and 6. Right? You can use negative indexes too. So Python slice operator, super handy. Right? The corresponding, you can't slice a string in Java, but there is a method called substring that does more or less the same thing. Right? You can't use negative indexes. However, it works exactly the same way. Right? The indexes you pass in are otherwise exactly the same as the slice. No colon. Right? So it's either, if you pass in 1 index, right, then it assumes you want the rest of the string starting at index 1. Right? So that's as if you had written 1 colon in Python. Right? 3, 4, give me the substring starting at index 3, up to but not including index 4. Right? So there you get the D. 5, 7, give me the substring starting at index 5, up to but not including the 7. Right? So characters 5 and, at indexes 5 and 6. Right? Exactly the same as the Python slice. Python lets you compare strings using less than, greater than, equals, equals, right? Not equals, less than or equal to, right? These all work in Python. Right? So in Python, you are allowed to do what's called operator overloading on your classes. Right? In other words, you can redefine how the operators work. Right? So is S less than T? So is A less than Z? The answer is yes, right? Because A comes before Z in the alphabet. Right? Is S greater than T? Obviously no, right? Z comes after A. Right? Are they equal? Oh, is S equal to A? The answer is yes, right? In Python. Right? So equals equals in Python, dot equals Java. All right, so can you do the same thing in Java? The answer is unfortunately no, even though strings are special. Right? So in Java, you use what's called the compareTo method to compare two strings for order. Right? And so the way it works is you have two strings, S and T, right? And then you write S dot compares to T, or T dot compares to S. Right? So S dot compared to T, right? CompareTo always returns an integer value. Exactly what the integer value is, you don't really care. Right? What you care about is the sign of the integer value. Right? So if the sign of the value that's returned is negative, right, then S is less than T. Right? If the sign is positive, right, then S is greater than T. Right? If the sign is, if the value is 0, right, then you have to look at what exactly compareTo says it does. Right? Most of the time, if it's 0, then S and T are equal. Right? So for strings, it's always the case that they're equal. The strings are equal if you get back 0. Right? But you can implement compareTo for any class that you want. right? And you can change what the meaning of 0 means in those cases, right? We'll look at examples of those later on in the course, right? So s dot compare to t. If it's negative, s is less than t, right? S dot compare to t. If it's positive, s is greater than t. So for example, if we have the strings aardvark and zebra, right? What is the value of s dot compare to t, right? Well, is s less than t? The answer is yes, right? So you get back a negative value, right? What about s dot compare to s? Right? So what if I compare s to itself? Well, they're the same string, so they're equal, right? So I get back 0. What if I switch the order of s and t, right? So t dot compare to s, right? So if t is greater than s, or if t comes after s in the alphabet, right, it'll return a positive value, right? So I get back here some value that's greater than 0, right? Is there anything else? T dot compared to t is also 0, right? Because t is equal to itself. Let me just quickly, okay, this is the last slide, and then we'll call it quits for today. So there's a bunch of, there's a few different replace methods. So you can replace all occurrences of a character or all occurrences of a substring in a string. You get back another string, right? You don't actually change the characters in the original string. So here I've got the string sparring with a purple porpoise, right? So lots of p's, right? I'm going to ask s to replace all characters p with the character t, right? And so if you replace all the p's with t's, you get starring with a turtle tortoise. Right? You can also replace strings or substrings, right? So hi ho, it's off to work we go, right? So I can ask the string s to replace all occurrences of hi ho with oh no, right? And now you get oh no, it's off to work we go, right? And so replaces all occurrences of a string or a substring, right? But it always gives you back a new string, right? It doesn't modify the original string. So things to remember about today's lecture, right? Strings are immutable, right? If you call a method on a string and it looks like it changes the string, it doesn't, right? It returns a new string that's equal to the modified string, right? If you're comparing two strings for equality, use equals equals, right? Do not, sorry, use, if you're comparing two strings for equality, use dot equals, right? Do not use equals equals, right? All right, that's it for today. Look for your assignment later this evening. It'll be due in a week.